You know, when you think of plants, you probably don't think killer. But in the quiet world of botany, there are some silent assassins. Today, we're diving into the brutal and, honestly, fascinating world of carnivorous plants. These things are highly evolved killers. They don't hunt for sport, they do it to survive, usually because they grow in soil that has almost zero nutrients. And we are about to witness the ultimate showdown.
So, here's the big question for today's explainer. What happens when you pit 50 hungry Venus flytraps against a whole swarm of 1,000 flies? Are the plants going to get overwhelmed by the sheer numbers, or are those flies just walking straight into a massacre?
But there's just one little catch. Our 1,000 flies are starting out as larvae, and they need about a week to hatch. But hey, that waiting period is actually the perfect excuse for us to go exploring. Think of it like we're doing a few side quests before the final boss battle.
Okay, for our first side quest, we're starting small, and I mean really small. Meet the miniature Venus flytrap. Its jaws are about 10 times smaller than a regular one, but its hunting mechanism just as wild.
And this incredible mechanism scales down perfectly. Just like their bigger cousins, these tiny traps ooze a sweet nectar to lure in their prey. The unsuspecting insect comes in for a drink, brushes up against those super sensitive trigger hairs inside, and bam! The jaws snap shut in an instant.
But it turns out, size really does matter. First, we tried a flightless fruit fly, which weighs a measly 0.003 grams. It was so light it could basically do a little dance all over the trigger hairs, and nothing happened. But then we introduced a tiny cricket. It was just heavy enough that while it was distracted slurping up that nectar, it tripped the hairs and got caught. It was a close call for sure, but the plant won that round.
All right, next up, we have a plant that doesn't use a snap trap at all. Now, its strategy is much more passive, and you could argue way more devious. Let's meet the sundew. So instead of jaws, the sundew has these long stems that are covered in these tiny red hairs, and each one secretes this super sticky, glue-like nectar. The second an insect touches it, it's stuck for good. It's less of a trap and more like living flypaper. So we tested this out with another cricket, and something pretty hilarious happened. This cricket was smart. It used its long antenna to dip right into the sticky stuff, pull them back out, and then lick off the sweet nectar. It was totally outsmarting the plant, getting a free meal for over 30 minutes. Now that clever cricket might have won that battle, but the sundew has evolved to hunt a very specific kind of prey, one that isn't quite so brilliant. The sundew's absolute favorite meal is the flightless fruit fly. See, they're drawn to the nectar just like the cricket was, but they're way too small and weak to ever pull themselves free from that glue. The plant can easily trap dozens of them all at once. And its eating process is, well, it's pretty brutal. As soon as a fly gets stuck, the little sticky hairs start to curl around it. Then the whole stem slowly wraps around the prey, and finally, the plant secretes an acid to dissolve its meal. It's a slow, gruesome, but very effective process. This brings us to our final side quest, and I gotta say, this might be the most brutal hunter of them all. This plant doesn't snap, it doesn't stick, it drowns its victims in a pit of acid. This is the pitcher plant. Its whole mechanism is called a pitfall trap. At the top of its stem, there's this leaf that acts like a lid, covering a deep hole, or pitcher, and that hole leads straight down into a pool of digestive fluid. It's an elegant design, but also absolutely terrifying. And it is virtually inescapable. The nectar on the inner walls is incredibly slippery, and to make matters worse, there are these downward-pointing hairs that make it impossible to climb out. Once an insect slips, that's it. It falls right into that pool of acid at the bottom. When we tested this with a cricket, man, it was over in seconds. The cricket was just kind of exploring the rim of the pitcher, and the next thing you know, it slipped right in. This plant is just a perfect, lightning-fast trap that's been evolving for millions of years. The cricket was now just sitting in a pool of acid, about to become plant food. All right, our side quests are officially complete. And, more importantly, our fly larvae have hatched. You know what that means. It's time to get back to the main event and finally answer our big question. So, the moment of truth. What happened when we finally unleashed hundreds of flies onto 50 hungry Venus flytraps? Was it the epic battle we were all hoping for? Well,
Not exactly. In a pretty surprising twist, the experiment was a bit of a fail. The newly hatched flies were just, well, super inactive. They weren't really flying around or exploring, they mostly just sat there, which meant very few of them ever wandered into the traps.
But don't you worry, luckily, our friend over at the YouTube channel Flytrap Films did a similar experiment, and they let us share their incredible footage. See, he used rotten meat to attract a massive swarm of very active flies, giving us the epic battle we were all waiting for. And the results were insane. With so many flies swarming the plants, the traps just went into a feeding frenzy. It was absolute chaos. In this one record-breaking moment, a single trap snapped shut and caught 6 flies at the exact same time. That's the most he'd ever seen, a true multi-kill.
He also tested the pitcher plant, which acted like a literal vacuum cleaner. Apparently, when an insect flaps its wings right above the opening, it creates this weird vacuum effect that just pulls the bug down into the pitcher's acidic doom. The plant was so effective, so relentless, it actually started to overflow with its victims.
Seeing these plants in action is just incredible. They're not just these passive things sitting in the dirt. They can be active, strategic hunters, all because evolution forced them to adapt to some really harsh conditions. And that leaves us with one final thought. If evolution created these perfect killers out of pure necessity, what other secret, incredible abilities are hiding in the plant kingdom, just waiting to be discovered?